Welcome to section 11.6, Solving Radical Equations. In order to solve radical equations, we will adopt the following strategy. First, we will rewrite the equation so that only one radical containing a variable is by itself, isolated on one side of the equation. Second, we raise each side of the equation to a power equal to the index of the radical. The purpose of this is that raising to that power will cancel out that radical and so remove the radical sign. Next, we combine like terms. For the fourth step, if our equation still contains a term with a variable in the radicand, we repeat the steps again 1 through 3 until no radicals remain. For step 5, we solve the resulting equation for the variable. Once we do that, we could have introduced extra solutions or extraneous solutions, solutions which are not really solutions because we didn't solve the original problem, we solved the modified problem when we raised both sides to the power equal to the index. So we have to go back and check our original solutions to determine whether they are truly solutions. Let us consider our first example. Suppose we are asked to solve and check our solution, and if the equation has no real solution, to state that it has no real solution. Our equation is the square root of x is equal to -2. First of all, let us recall that the square root of x is the positive real number, which when multiplied by itself, squared, gives us x. Because the square root is only positive, it cannot return a negative value. Therefore, this equation has no solutions. Suppose, for example 3, we are asked to solve and check that the cube root of 2x plus 5 is equal to 7. We begin by isolating the radical, cube root of 2x. Subtracting 5 on both sides gives us the cube root of 2x is equal to 2. Now raising both sides to the third power so that we cancel the radical, we have the cube root of 2x cubed is equal to 2 cubed. This means that 2x is equal to 8. If 2x is equal to 8, then x is 4. Now if we are asked to check our solution, we take our answer, x is equal to 4, plug it back into the original equation, so we have the cube root of 2 times 4 plus 5 is equal to 7. Well, the cube root of 2 times 4 is 8, plus the 5 is equal to 7. Well, the cube root of 8 is 2, so that 2 plus 5 is equal to 7, or that 7 is equal to 7. Because we get a true statement at the end, our solution is x equal to 4. For our third example, suppose we are asked to solve the square root of x plus 4 equal to the square root of x minus 4. Since both radicals are isolated, we raise each side to the second power to cancel the radicals, so that we have the square root of x plus 4 squared is equal to the square root of x minus 4 squared. The radicals cancel, and we are left with x plus 4 is equal to x minus 4. Solving this equation, we subtract x's on both sides to give us x plus 4 minus x is equal to x minus 4 minus x. The x's on both sides cancel out, and we are left with 4 equal to -4, a false statement. Because this is a contradiction, a false statement, we have no solution. As our final example, suppose we are asked to solve the square root of 5y plus 16 minus 2 minus y is equal to 0. Our first step is to isolate the radical. We add 2 onto both sides and we add y onto both sides, giving us the square root of 5y plus 16 is equal to 2 plus y. Now, squaring both sides so that we cancel the square root gives us the square root of 5y plus 16 squared equal to 2 plus y squared. Canceling the radical, we have 5y plus 16 equal to 4 plus 4y plus y squared, which is what you get when you expand your quantity 2 plus y squared. Next, we turn this equation into a quadratic equation for which we are familiar with the solutions. Subtracting 5y plus 16 on both sides gives us 0 is equal to y squared minus y minus 12. Factoring, this gives us 0 is equal to y minus 4 times y plus 3. Therefore, that we have possible solutions y equal to 4 by setting y minus 4 equal to 0, and y equal to negative 3 by setting y plus 3 equal to 0. Checking the solutions, we see that plugging in negative 3 for y gives us the square root of 5 times negative 3 plus 16 minus 2 minus a negative 3 is equal to negative 15 plus 16 under the square root minus 2 plus 3, or the square root of 1 plus 1 is equal to 0. But the square root of 1 is 1, so we have 1 plus 1 is equal to 0, or 2 is equal to 0, giving a false statement. Testing 4 for y, we have 5 times 4 plus 16 under the radical, minus 2 minus 4 equals 0. 5 times 4 gives us 20 plus 16, so that we have the square root of 36. Minus 2 minus 4 gives us negative 6, so that the square root of 36 is simply 6 minus 6, or 0 equals 0. This is a true statement. Therefore, our only real solution is x equal to 4.